Welcome to this video. In this video I'm going to talk about the factor theorem and the remainder theorem, and hopefully this video will be pretty short, concise, and look at one example. The factor theorem states that a polynomial x minus k is a factor of the polynomial f of x if and only if f of k is equal to 0. And what we do is we use the remainder theorem to determine that part. If a polynomial f of x is divided by x minus k, the remainder is equal to f of k. So put these two together. If we can find the remainder equal to 0, because f of k would be 0, then our polynomial x minus k is a factor of the polynomial f of x. So let's take a look at an example. So we have this function 2x cubed minus 5x squared plus 22x plus 15. The question is x minus 3 a factor of f of x? So what we're really asking ourselves is f of 3 equal to 0? That's our question. Because if it is, then x minus 3 is a factor using the factor theorem. Well, I'm going to use synthetic division. And we're going to plug in our coefficients. And 3. Okay, recall in synthetic division, we're going to bring down the 2, multiply, then add. We're going to get negative 9, multiply, then add, multiply again, then add. And look at that, lo and behold, we got a 0 as a remainder. So since the remainder is 0, the remainder theorem says that f of 3 is going to be 0. And since f of 3 is 0, the factor theorem says that x minus 3 is a factor. Well, that's all great, but why would we want to really do that? Well, with a polynomial with a higher order than 2, okay, if we had a quadratic, we could just factor it. But we don't have a quadratic, we have a cubic, and we can't just factor. So we know now that x minus 3 is a factor. We also know that this is 2x squared minus 9x minus 5. Maybe this can also be factored. So, in fact, it can be. And if we factor this quadratic, we're going to get 2x plus 1 and x minus 5. Well, we already know that x minus 3 is a factor, so I'm going to add, not going to add, but I'm going to include x minus 3 here, and I've got my function now, 2x cubed minus 15x squared plus 22x plus 15. I have it now in factored form. So I have a polynomial in factored form, and if you go back to one of the videos or something that we have done in class, you know that since it's in factored form, I could find all of the zeros, which are the x-intercepts, by setting each of these factors equal to 0. So I would have 2x plus 1 equals 0, which would give me x equals negative 1/2. I would have x minus 5 equals 0, which would give me x equals 5. And I would have x minus 3 equals 0, which gives me x equals 3. So I've found the 3 zeros of f of x. So if I knew one of the factors, I could synthetically divide to get this down to another one lower power, one lower degree, and then I can use just regular factoring to factor it out. Well, you know, sometimes we wouldn't want to use the remainder theorem just to kind of simplify our life a little bit. If I wanted just to evaluate f of 4, well, I could plug in 4. Okay, so that would be 2 times 4 cubed minus 15 times 4 squared plus 22 times 4 plus 15. And then if I continue to do that work, because I'm going to want to get all of that calculated out here, I'm going to have 2 times 4 cubed is 64 minus 15 times 4 squared is 16, plus 88, plus 15. All right, these numbers are getting a little large here. 128 minus 240 plus 88 plus 15. Add them all together and get negative 9. So, this is kind of, these numbers are kind of large to have to deal with. So we know that by the remainder theorem, if we did synthetic division, we should be able to get the remainder right here equal to that number. Let's see. So I'm going to bring 2 down, multiply, I'm going to get 8. 8 minus 15 is going to be negative 7. Negative 7 times 4 is negative 28. Add those together, I'm going to get negative 6. Negative 6 times 4 is negative 24, and I get negative 9. Look at that. So this was a lot quicker, and we had smaller numbers to deal with than this over here. So this is maybe something we would want to use the remainder theorem for. Okay, that's it. That's all I have for you on this video. So I hope this helps with the factor theorem and the remainder theorem.